Good morning. In this video lesson and this entire week, we're going to continue to work with solving equations. But specifically, we're going to start focusing on the number of solutions, or how many solutions our linear equations have. Last week, and when you worked in 7th grade, every linear equation, or one variable equation that you solved, had exactly one solution. But today and this week, we're going to have to start recognizing that not every linear equation has exactly one solution. Specifically, some equations are going to have no solutions at all. Some equations are going to have infinite solutions. Let's take a second to talk about that here in the objectives. We see e.g. E.g. means for example, and anytime I see e.g. or for example, they're going to show me something that helps me understand what I just read. Some equations have no solutions. How can that be? What if you have an equation like x plus 1 equals x plus 2? It doesn't matter what value you pick for x. The left side is always going to be one less than the right side because they look like the same expressions, except this side gets a plus 2, this side gets a plus 1. And that same idea, some equations can also have an infinite number of solutions, or tons and tons of numbers. In this case, any number you pick for x is going to work for both sides of this equation. If I take x plus 2, I'm going to give you a couple examples on a whiteboard here. If I take x plus 2, and that equals 2 plus x, as you kind of see down here, when I make x1, 1 plus 2 is going to be the same thing as 2 plus 1. They're both going to just make 3. I could have also picked any other number. I could pick 5 for x, and then it would just become 5 plus 2 equals 2 plus 5, and that would say 7 equals 7. So we start to see for this equation here, x plus 2 equals 2 plus x, any number we pick for x is actually going to make a true statement or work in the equation. The equations are going to get more complicated today. Then you're going to have to solve some linear equations like last week and recognize that some of these complicated equations boil down to infinite solutions or no solutions. Let's take a look at the guided problems. For the guided problems, we're presented with two equations. We're presented with a green equation, x plus 3 equals 3 plus x. That's what you see on my whiteboard up here too. And then for the purple equation, we're also presented 2y minus 3 equals 2y plus 2. Part 1, and this is where you're going to pause the video, says use inspection, or figuring out these equations in your brain, to determine the number of solutions to each equation above, and explain each of your answers. So go ahead, take a look at this green equation first, figure out how many solutions would this green equation have, and then provide an explanation. After you do that, do the same thing for the purple one. How many solutions are we going to end up having for this purple equation? Hopefully you've paused the video. Welcome back. We're going to take a look at this on my whiteboard a little bigger. The first green equation, hopefully you recognize this is another one where x has an infinite number of solutions. Some of you may remember this symbol here. This symbol means infinity. Just to save some time, it's a sideways 8 basically. I recognize just by inspection this equation is going to have an infinite number of solutions. Why is that? Because it's really the same expression on the left as it is on the right. X plus 3 is always going to make the same thing as 3 plus x. I know that if I pick different numbers, what if I pick a 1 for x? Will 1 plus 3 be the same thing as 3 plus 1? Of course, they're both going to give me 4. Or what if I pick a different value? What if I pick 5 for x? This side would be 5 plus 3 equals 3 plus 5, and both sides would just say 8 equals 8. So x could be equal to 5, x could be equal to 1. I could even pick a value like 1,000,000. This would be 1,000,003. 3 plus 1,000,000 would also be 1,000,003. It doesn't matter what I pick for x, there's an infinite number of solutions. We were also asked to consider the purple equation. Look at that with inspection. Here's the purple equation. 2y minus 3 is equal to 2y plus 2. So after you explain why this one has an infinite number of solutions, purple, which we're going to full screen again, is going to be an equation that has no solutions. Why is that? Why is the variable y going to have no solutions at all on this equation? Because the variable term on the left expression and the right expression is identical, 2i and 2y. on this side, we're always going to subtract 3 from whatever 2y is. On this side, we're always going to add 2. So as this goes up by 2, this goes the same number, goes down by 3. This side's always going to be 5 bigger. So this one has no solutions. And at this point, I want you to pause this video again. And for part 2, it says attempt to solve each equation by using inverse operations. Those are the opposite operations, adding and subtracting, to gather and combine like terms, or to get the variables together on the same side. You're going to insert images of your work, and we're going to think about what happens when we try to solve the ones with no solutions. That's the purple equation here. And what happens with infinite solutions, or the green equation. So you've paused the video, you've tried to solve these step by step or using inverse operations, and that's what we're going to take a look at here. How come x has an infinite number of solutions, or what will this look like when we solve by inverse operations? Well, we see in blue boxes, the variable terms are on opposite sides of the equation, and the constants are on opposite sides of the equation. I need to get this blue box, this positive x, on the same side as this positive x so that I can combine the variable terms. I do that by subtracting x because that's the opposite of a positive x. Positive x minus x is eliminated. I need to do the same operation here, and what do I see? On both sides of the equation, because the variable terms were identical, positive x and positive x, they eliminated each other when I tried to gather them to the same side of the equation. The only thing that was remaining is a true statement. 3 equals 3. So what do I recognize here? This equation is telling me 3 is always equal to 3. It's saying whatever I plug in for x, it's going to simplify to a true statement or something that works. In this case, 3 equals 3. So if I make x positive 2, it'll say 5 equals 5. If I make x positive 6, 6 plus 3 would say 9 equals 9. But no matter what happens, whatever I plug in for x, this will always boil down to a true statement. So this is the equation's way of telling me I have infinite solutions. So whenever I see an equation boil down to a equals a, just a number equal to another number, it's the equation telling me any value for x works. What happens for the other equation, the one that had no solutions? Again, here we see variable terms on both sides of the equation, positive 2y and positive 2y. So when we try to gather those, subtracting 2y from the right side to eliminate a positive 2y here, I eliminate the variable again on both sides. 2y minus 2y is nothing. 2y minus 2y is nothing. But this time, I'm left with a false statement. Negative 3 equals positive 2. Negative 3 can never equal positive 2. That's a false statement. That will always be a false statement. And this equation is screaming at me, no matter what you plug in for y on both sides of the equation, the left side is always going to be 5 smaller than the right side. Negative 3 is 5 less than positive 2. So if I subtract 3 from 2y on the left, it's always going to be 5 units smaller than adding 2 to 2y on the right. No value for y or no solution in the world can work in this equation. So if your variables disappear and the equation boils down to say something that's never true, like a equals b when a and b are different numbers, that's the equation's way of telling you there are no solutions. There's an optional challenge problem right here now, so you should pause this video. At this point, you have everything you need, I guarantee, to work today. The optional challenge problem is just a little fun for students ready to look at the most difficult equation. So I'm going to run through that on a whiteboard quickly. But again, I would not be doing the optional challenge problem. Right now, I would be moving on to the practice problems 1, 2, and 3. Let this load for a second. So at this point, I would go to practice problem number 1 and start working there. But if you want to pause the video and work out the pink equation, I'm actually not going to have time to do that. But it says 3f minus 4 equals negative 1/2 times 4f minus 8 plus 5f. You're going to have to distribute first here. I'm down to about 10 seconds. So this becomes negative 2f plus 4 when you do negative 1/2 times there. And negative 2f plus 5f becomes 3f. So it becomes 3f plus 4 and 3f minus 4 on the other side. The f's are going to eliminate